So when we try to take this limit, we have no strategy to simplify it, to change it by factoring, by rationalizing it. There's really no trick to changing the way it looks and then plugging in 2. So I will tell you this one does have a vertical asymptote, and I'm going to show you why that's going to happen. So when you're stuck and you have no other way to do it, you want to use a table, which then graphs it for you to see what's happening, because it's most likely an asymptote or something awkward. So what we're going to do here is we're going to make a table of values. All right, we have x and y. All right, right in the middle of the table is going to be 2, because that's what we're approaching, and we're going to come from both sides. We're going to put several points from both sides and see what happens. Now from less than 2, I'm going to do like 1.5, 1, and 0. From above, I'll go 2.5, 3, and 4. All right, so I'm kind of working above, working below, going to plug in some values. All right, so when I plug in 0, if I plug in 0 right here, let's do each one by one. So 3 divided by 0 minus 2 is negative 1.5. 3 over 1 minus 2 is negative 3. 3 over 1.5 minus 2, a little bit harder there, that's 3 over negative 1/2, which becomes negative 6. Then this we don't know. Okay, we're going to come from the other side now. 3 over 2.5 minus 2, that would be a positive 6. 3 over 3 minus 2, which would be a 3. And 3 over 4 minus 2 is a 1.5. All right, now you look at that and go, what does that look like? I don't know. I don't have a clue what's happening. Well, if I chose smaller numbers in here, you're going to notice it's going to go to infinity or negative infinity. And this is going to go to infinity, negative infinity. Now, some of you might be able to tell that these values are getting bigger in the negative direction, and these are getting bigger in the positive direction. So you might be able to visualize it without the picture, but I'm going to show it with the picture because I just think it's easier. We're going to do a very, very quick sketch. So this would be 1, 2, 3, 4. We have an asymptote at 2, which that's what you'll see. All right, and as you see this, we'll call this negative 6 down here. We'll call this positive 6. And you can see at 1.5 we're there. Then we're here. And then at 0, we are right here. So if you look at this graph, you will see it's going like that. All right, which if you can tell, it's going towards negative infinity. And then the other side of this graph, well, this one would be here at 6. At 4, it was halfway at 3, then 1.5. And what you see here is this graph will kind of look like that, which this is going to positive infinity. So my question is, if this is an asymptote and they go opposite direction, what's my answer? And hopefully you realize your answer is does not exist. There is no answer. There is no limit. It goes to no specific spot. They're both going opposite directions. Now, I want to add to this problem. What if I asked the limit as x approaches 2 from the negative side of 3 over x minus 2? What would that equal? Well, if we look at this from the negative side, isn't it going to negative infinity? So I would call that as negative infinity. Or what if I asked for the limit as x approaches 2 from the positive side of 3 over x minus 2? What does that equal to? Well, if you look at this, isn't that going up forever? So wouldn't you say that one would be positive infinity? And you can tell they don't agree. That's why there is no limit. And limits that we can't really do tend to be these asymptotes. And we're going to next talk about tricks to notice asymptotes and make it a lot easier to know about asymptotes.